This video is going to cover the topic of significant figures, which I typically abbreviate and just call sig figs. So that's what that means when you see that written out or when I say that. So there are really two big goals that we need to think about with significant figures. One is the technical goal of what really are the best practices. What are the things that we're trying to do when we use sig figs? The second aspect is to think about why we're using sig figs. That really the big learning outcome that this relates to is the idea of communication. That when you circle an answer, when you have the result of some problem that you're solving, and you're trying to communicate that to someone else, the number of decimal places that you're writing down, your number of sig figs, actually communicates something in particular. So sig figs aren't just some technical rule that people have created to make you lose points on your homework. It's really an important part of communicating your results. So that's why we need to talk about this, and that's why you need to make sure throughout this class and your future work that you're using the appropriate number of significant figures. So what are sig figs? So the first thing that we need to do is agree on what does it mean for something to be significant. And where this is really helpful is to think about scientific notation. So the figure here, which is just the example coming from the book, actually indicates two different ways of writing a number. So one is written just in the normal decimal form, another's written in scientific notation. Now if we start on the scientific notation side, 6.20 times 10 to the negative 3, you see that there are three significant figures here. And the reason we would say that is there are literally 3 digits written down. Now, when it's written in a decimal format, it's a little less clear how many significant figures there are. The rule is that leading zeros, i.e. the zeros to the left of the numeric values, are not significant. So there's also 3 significant digits here. That trailing zero, the zero the farthest to the right, is significant, and by writing that 0 there, you're specifying what the value is. You're specifying that this is not 6.21 or 6.29 times 10 to the negative 3. It's 6.20. So the zeros on the left just tell you the place value, but the 0 on the right is actually significant. Another place to think about this is if I gave you the decimal number of 0.10056, and said how many significant figures are there, the first thing to know is that that 0 to the left is not significant. However, these zeros in the middle are. So we would then have 1, 2, 3, 4, 5 significant figures in this number. So please make sure that you understand what is and is not a significant figure. This might be something that you've learned about before. It might be new. One thing to know is that it's always easiest to write your values in scientific notation so that you understand how many significant figures there are. The reason that we're talking about this is that as you do calculations or as you report answers, you want to have the correct number of significant figures. Sometimes when you do mastering physics homework, it will explicitly say to write your answer with 2 or 3 significant figures, so you need to know what that means. There are a few rules when working with significant figures, and especially when reporting your answers. So the first is that you need to use the appropriate number of sig figs. And again, in a little bit, I'll explain why this is really essential to communication, but you do need to think about what are the correct number of significant figures in your answer. Now, if you've done a calculation, you need to propagate through the correct number of significant figures. So if you have, for instance, multiplied, divided, or taken a square root, you want to look at your values and match the number of significant figures in your answer to the least precisely known number that went into your calculation. So if you multiplied 2 numbers where one had 2 sig figs and the other had 5, your answer would only be reported with 2 significant figures. Now, it's slightly different if you're adding or subtracting numbers. In this case, you don't actually use significant figures, but you look at the decimal places. So for instance, if I wanted to add 2 numbers where one had 4 significant figures, but the other perhaps even had more, you wouldn't just look at the number of significant figures here. You would actually look at your decimal values. So I could just put zeros here as placeholders and hopefully not mess up this addition when I do it. We see that we have way more significant figures than we started with, so there's no way that that would be our answer. But what you want to say is that this was actually what we knew. So this part is okay, but this we really can't factor in. So this would be a reasonable answer here. It wouldn't be reasonable to include those last 4 because you really just don't have information of what these digits actually are. So I know that that's not a complete example. There are problem-solving videos posted that go through in more detail and especially show you examples for multiplying, dividing, and taking roots. The last thing to think about is that whenever you want to cut down your number of sig figs because you have too many digits currently in your number, you're going to use rounding to do that. And it's important to not really round too heavily until the very end. Now, the best way to do this is to actually use variables through all of your work and all of your calculations and only plug in numbers at the very, very end. Now, in the case where you're unable to do that and you actually need to plug in some values early, you're encouraged to keep 2 additional digits so that you're not just rounding early and losing some accuracy. However, depending on what you're doing, such as taking roots, you may want more than that, or for instance, if you're squaring. However, again, the best practice is to just plug in numbers at the very final step rather than rounding early. So now I want to highlight a little bit why significant figures are communication, why it's not just a silly physics rule. So this picture I'm showing here of this bridge that doesn't connect might not be something that actually happened, but you can imagine the scenario. If you have a very wide river and people are trying to build a bridge across it, it makes sense to start on each side. However, the bridge needs to align in the middle. So not only do you need to have your starting position correct, you also need to have your starting angle correct on each side. So if someone is making a measurement, they need to know exactly how many digits are in their value. So if you've measured an angle and you've measured 32 degrees, is that 32? Is that 32.1, 32.105? You can imagine that there are many numbers that are similar but actually have different levels of accuracy. So when you're talking to other people, significant figures is how you describe what accuracy or precision you actually have. And this really comes down to measurement. Now, one thing to realize is that we're not always going to be making measurements ourselves in this class. We're frequently going to be using information that the book or perhaps a problem in class has provided. So in that case, you trust that the person telling you the information is actually telling you the information with the appropriate number of significant figures. So one example, a real-world example, kind of outside of physics, is, for instance, if I'm driving from the airport to my mother's house, I might tell her that I expect to get to her house at 4:13 in the afternoon. Now, if I'm doing that an hour early, she can probably assume that I've used my phone to map the drive and I'm using an estimate from my phone. She might guess that there's a few minutes of uncertainty in that, but that there's probably not an hour of uncertainty. If I'm telling her that I will get there at 4:13, that assumes that I'm not going to stop and watch a movie along the way, for instance. On the other hand, if I tell my mother that I'm going to get to her house around 5, she might expect that there's maybe 15 minutes or half an hour of uncertainty in either direction. Maybe I'm planning on stopping for a meal, but I don't actually know how long that's going to take. On the other hand, if I tell her that I'm going to get to her house in the evening, perhaps this is weeks ahead of time and I haven't even bought my plane ticket yet. There's really hours of uncertainty in that. So we do this all the time in our real lives, even outside of physics class, so it's important to think about when we specify a value, if we specify it with more precision, that really implies that we know that value very well. So one example that's a little more related to what you'll see in physics is, for instance, measuring the length of a screw. So if I tell you what the length of the screw is, I can tell you with different levels of significant figures, each one representing a different type of measurement. So for instance, if I tell you that the screw is 2 centimeters long, I may have gotten that measurement by using the fact that the width of my finger is just about 1 centimeter. So I've used that to really just estimate the length of the screw, and I'm telling you it's 2 centimeters. You really don't know if it's 1.6 or 2.4, but it's 2. It's closer to 2 than it is to 1 or to 3. On the other hand, I can use a ruler. And on this ruler, I've lined up my screw here, and I've measured 2.4 centimeters. Now, depending on the ruler, maybe I can actually get another digit here, but maybe not. So 2.4 centimeters, I've used a ruler. Now, a better way to actually measure the length of the screw is to use a calipers, where you put your screw in between the jaws of the calipers and then adjust it very tight, and there's a digital readout here. There's also analog versions. And in this case, you see that this measurement now has 4 significant figures. It's very precise. Now, in a way, we would not say that this finger measurement and the caliper measurement disagree. They actually do agree. However, they are reported with different numbers of significant figures. If you were looking for a screw that's about 2 centimeters long, using your finger to estimate it would have been fine. But if, for instance, you're making an automobile and you want it to be put together in a very precise way, you probably would actually use calipers for that. So again, remember that when we're using significant figures, we're really communicating how well we know something. So to briefly summarize, significant figures relates to how many decimal places are accurately known. And what that means will matter a little bit on the context, but it really relates to the fundamental way that the value has been measured. Usually for problems, you're going to be told how many significant values each initial input has. So this is something that we really only need to worry about for quantitative numerical answers. And remember that whenever you're writing down a result or an answer, the significant figures that you write down should be determined from the input data, whether that's a measurement you've made yourself or just values you've been told in the problem.